Okay, good. In this lesson, we shall focus on mathematics, Euclidean geometry for grades 11 and 12, past exam questions, and we begin as follows. In the diagram, O is the center of the circle. There it is. O is the center of the circle, and ABCD is a cyclic quadrilateral. OB and OD are drawn. OB and OD are drawn. If angle O1 is 4x plus 100 degrees, the angle C is x plus 34 degrees, calculate giving reasons the size of the angle x. We want the size of x. Right, we want the size of x. If we already know that the angle O1, which is exactly this one here, is actually exactly 4x plus 100 degrees. This one is x plus 34 degrees. So the question then is, what exactly is this here? We want to find the size of x. You have 3 minutes. Please let us know when you're done. Then we discuss together. Please let us know when you're done. Then we discuss together. Right, so please let us know when you're done. Then we discuss this together. Please let us know when you're done, and then we discuss these together. How far, Lisedi? How far, Lisedi? Are you done, Lisedi?
I'm almost done, sir.
All right, thank you.
X equals to 22.
Okay, that's fine. You're practicing, and obviously, let's check together. We'll always check, but first we know that the angle O1 is 4x plus 100 degrees. Why? Because it is given. The angle A
Oh, okay.
so now because this angle, so now we know that the angle O1 is actually 2 times the angle A. It is 2 times the angle A. The angle O1 is 4x plus 100 degrees. It is 2A, which means that the angle A is actually 2x plus 50 degrees. Right. So that then in the end, what we're then getting here, it is 2x plus 50 degrees. Which means, therefore, so we continue. We continue. So that then we have the following. So we got the angle A, but now we then from here are aware that angle A is 180 degrees, opposite angles. Of cyclic quad. So the angle A is 2x plus 50, which is x plus 34. Three x 180 minus 84 degrees.
98, 96.
Well done. And therefore, x
It's gonna be 32.
is going to be 32 degrees. Well done. It's going
Yes,
to be
sir.
32 degrees. So they are just a small difference there. Because I'm not sure if you got 32 or you got 22. Okay, so one of those, but the answer is 32 anyway. Right, so any question on this one? Anything you don't understand on this one?
No, sir.
Okay, move on to the next question.
Yes.
In
Yes,
the
sir.
diagram, O is the center of the larger circle. OB is the diameter of the smaller circle. Chord AB of the larger circle intersects the smaller circle at M and B. Write down the size of angle OMB. Write down the size of the angle OMB. Write down the size of the angle OMB. Provide a reason here. Okay, I'm just saying stuff, but what do you think the size of OMB is and why? What do you think the size of angle OMB is and why? Right. Right, so how far?
So I'm just getting a reason.
Okay, good.
Oh, so it'll be 90 degrees angled in a semicircle.
It will be 90 degrees angle in a semicircle, yeah? Because obviously you have been told at this point that O is the center of the larger circle and OB is a diameter of the smaller circle. If this is a diameter, it's against an angle of how many degrees here? At 90 degrees, it's circumference. And that is the reason, okay? So obviously, and there it is. So we have that the angle OMB, The angle OMB is actually exactly equal to what? 90 degrees,
90.
and it is an angle in semicircle. Angle in semicircle. It's an angle in semicircle. Next question. Right, if AB is what? If AB is the square root of 300 and OM is 5 units, calculate giving reasons the length of OB. We need the length of OB. Right, let us see what if you can get this one right.
Root 175, sir.
Okay, let us see what if that would be the correct answer. Obviously, that you've got. Let's see if that would be the correct answer that you've got. Let's see if that would be the correct answer that you have got. Okay, so obviously now the couple of things that you need to take note of. If the AB is the 300 is the same as 10, the square root of 100 is 10, and that is 3 units. So you'd have exactly that. AB is exactly that. So that if you divide this by 2, then divide 10 by 2, you'd have 5 the square root of 3, and this is 5 the square root of 3. So right now in triangle OMB, in triangle OMB, we're able to see that AB is the square root of 300, which is 10 the square root of 3. MB is 5 the square root of 3, which is line from center perpendicular to chord. OB squared OM squared plus MB squared, which is Pythagoras. OB squared is OM, which is 5 squared, and MB is 5 the square root of 3. And therefore, if you do, this is going to be 25 by 3 is 75, which is 100. OB squared which is 100, the square root of this, the square root of this, which means OB is 10 units. OB is 10 units.
Okay, so the thing is, I was doing it without a calculator. So what I had initially done is
Yes.
OB squared equals to 5 squared plus root 150
Okay.
squared.
Yes.
So
Okay,
then
that's fine.
that
I
goes to,
understand.
but
Yes.
now I got a calculator now. I finally
Okay.
got mine.
Okay, that's fine. All right, because we're going to be using it a lot. Because we're preparing for exams. This is the exam season. And so, all right. So we continue. So we continue. So we continue. Let's try the next question. Right, in the diagram, PQRS is a cyclic quadrilateral such that PQ equals PR, the tangent to the circle through P and R meet QS produced at A, RS is produced to meet tangent AP at B, PS is produced to meet tangent AR at C, PR and QS intersect at M. Proof giving reasons that angle S3 equals angle S4. We need to prove that the angle S3, so if obviously this is S, we need to prove that the angle S3 is equal to angle S4. Okay, so yeah. Okay, yeah, you have 2 minutes. You have 2 minutes. We continue. We continue. We continue.
So I won't even lie to you. I don't even know how to start.
This is a past paper for you. Okay, I understand. That's okay. This is the past paper, and we want to prove that S3 equals S4. We're trying to make sure that you go through the Euclidean geometry gymnastics and you can be familiar with the kind of computations you need to do in actually dealing with geometry. And this is the objective of us embarking on this journey. So, but I'm giving you 2 more minutes, then we shall start. Right, and then we shall start. I'm gonna give you the corrections, of course. I'm gonna give you the corrections, of course. I'm going to give you corrections, of course. Right. Right. We have 2 more minutes. Then we shall do the corrections because it's way too easy. Right. Then we will actually see what to do next. Right. We'll see what to do next. We'll see precisely what to do next. Right. We'll see what to do next. Right. How easy is it? You don't know where to start still.
Okay, so right now I'm just writing down angles that I know equal to each other, but I
Okay.
still
Understand. So we continue. We continue. We continue with our method of solving the problems. But instead, the aim is not just to give you answers to these, because with me, I've already solved all these problems. But I want to see what you can do, because I already know the answer. The answer is angle S3 equals the angle S4. But you see, the question is, I'm trying to train you to be able to do the questions. Because with me, I'm already a teacher. So I don't worry about this. I'm not worried about this. But I must train you. The way to train you is to give you some exercises. If I give you some exercises, then you try the exercises, then we can see how, okay, then you're able to do something. Then we can see that you're able to do something. Right, you're able to do something. Right, we're giving you a chance because we're going to give the corrections just now. But see, the reason we give corrections is to make sure that you're able to see exactly what needs to happen and what you're supposed to do. And corrections are always given when you can you can be in a position to try, and then you can give the corrections after you have tried. You know, and this is the whole aim of learning. Okay, let's do this one. It's too easy. Let us do this. It's too easy. Right, first and foremost, we know that the angle S3, because if you look at this here, and then you look at this, the angle S3 is equal to the angle PQR, exterior angle of a cyclic quad. So we know that the angle S3 is actually exactly equal to the angle PQR, which means that if exterior angle of cyclic quad exterior angle of cyclic quad. But also we know that the angle R3 is equal to PQR, angles opposite equal sides. Let's look at the angle R3. The angle R3 is actually exactly equal, because you know that PQ is equal to PR. So if PQ is equal to PR, it means therefore that R3 is equal to the angle PQR. Which means therefore that we have angles in this triangle. This is an isosceles triangle, so we have angles opposite equal sides. Therefore, the conclusion out of this is therefore that the S3 is equal to R3. S3 equals R3, but
But I'm still not understanding.
what is it that you understand?
So doesn't S3 equal to the whole of Q?
Yes, that is what we are saying. We're saying S3 is equal to the whole of Q. That's why we're saying S3 is equal to PQR. And
Okay.
PQR is the whole of Q. You agree? That S3 is equal to the whole of Q, but the whole of Q is PQR. Do you agree?
Okay.
And
Yes,
this is the exterior angle of a cyclic quad, But the angle R3 is equal to the angle PQR, because in this case, you have that this triangle, we have been told that PQ is equal to PR. PQ equals PR, so that this is equal to this. So the angle R3 is equal to PQR. You get the point? So that the angle S3 is equal to angle R3.
yes, sir.
Okay. Now, we have then the following. We have exactly the following. So obviously, because now, therefore, S3 is equal to R3 because they're both equal to the angle what? PQR. But the angle S4 is equal to the angle R3. The angle S4 is equal to the angle what?
R3.
R3. Why? Angles in same segment. Angles in same sag. because the angle R3 is actually exactly equal to the angle what? S4. These are angles in the same segment. And therefore, S4 is R3, S3 is R3, which means that S3 is equal to S4 as required. So we've proven, therefore, that S3 is equal to S4 as required. Any question on this one so far?
Yeah, so please re-explain S4 and S3.
Right, because
I mean R3, S4 and R3.
S4 and R3.
Yeah,
Okay,
so in the same
this
segment.
is S4. The angles in the same segment. Because you can see these here.
Oh, okay, I wrote that down. Yes, 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 I
Oh, you
can
wrote that
see
down. Okay, good. Because if you have angles in the same segment, you have the bow tie.
the bow tie. Yes, sir.
Yes, and so this angle is equal to this, and it's exactly what we are seeing here because it's like a bow tie here, and we have a bow tie there, meaning this angle here is equal to this angle there.
Yes, sir.
Okay, good. And therefore, we can see that S4 is R3. But if S4 is R3, we already know that S3 is R3. So now, which means, therefore, S3 is R3, but S4 is R3. So, which means S3 is equal to S4. And this is what we're supposed to prove. And therefore, we are done. So, any question on this so far?
No, sir.
We move on to the next question. Proof giving reasons that SMRC is a cyclic quadrilateral as M. Right, SMRC. So we have SM, there's R, there's C is a cyclic quadrilateral. Prove this one. Okay, so you have 3 minutes to prove this. It's too easy.
Okay. So what I'm seeing, wouldn't BP equal to CR?
Okay, you're still here, right?
Yes, sir.
Okay, good. Let's try it. Yeah, we have 2 minutes now. Too easy, this one. SMRC is a cyclic quadrilateral. Prove it quickly, and then we move
So wouldn't
forward.
CR equal to BP?
Okay.
The reason why I'm saying that is because of the tangents that meet at A.
Yes.
Usually tangents are equal.
Yes,
And
tangents from the same point are equal.
yes,
Tangents drawn from the same point outside the circle are equal to each other.
so and then where does it say it? Um,
So it's
R
enough. Yes.
is produced to meet the tangent at AP at B,
Yes.
and then PS is produced to meet the tangent at AR at C. So
Yes.
I'd assume that those two are equal.
Yes.
Given that those two are equal, wouldn't it also make up bow tie?
Which ones are equal so that they make a bow tie is made? Which particular angles? Please say that again. I need to make sure I understand you.
Oh wait, no, 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 I'm looking at the wrong
Okay, yeah, because
angles.
okay, yeah, it will be very interesting to like indicate the angles that are in a bow tie. You know, if you can indicate those angles that are in a bow tie, then we can be sure that okay, we have these angles in a bow tie. Right. Right, so too easy. Yeah, you have 2 minutes. You have 2 minutes. You have 2 minutes. Good, so we continue.
Hold on, sir.
Good.
Okay.
Remember, we are practicing here. We're not fault hunting. We're trying to train you because with me, I've already solved all these problems. I already know all the answers, you see. But it's not a question of me just giving the answers out. It's so wrong for the teacher to just go to class and just give answers without the students trying, because then it means that we are working backwards and we are working at running at a loss, and this can't be correct. So we therefore need to ensure that we practice. We therefore need to practice. We therefore need to practice. Right, too easy. I'm just giving you some easy problems, so yeah, be good. Just enjoy. But obviously, I'm gonna do the corrections every time because I've already solved all these. These are like thousands of geometry problems. But I want to make sure that you learn and try with me so that you don't just become that kind of person, student who is just used to be being spoon fed. We're not doing we're not just spoon feeding here. So this is not a feeding scheme wherein we're just feeding like feeding scheme. It's not a feeding scheme. It's not a feeding scheme. It's not a feeding scheme. We're not just spoon feeding. Right. We continue. We continue. We continue. We continue. Right, we continue. How far? How far? Are you done? Is it too easy?
Not yet, not yet.
Okay, because I'm training you to be a soldier at war. To be a soldier at war. Be a soldier at war. Okay, let's do the corrections because I can see that it's taking you time. But in as far as I can think, it's very easy. Let us do the corrections once and for all, and then we try the next one. Because we are training you here, but we're trying to make sure that Lesedi becomes a good geometry student, that you know how to find the things. But what you can see first is that the angle R1 plus the angle R2. The angle R1 plus the angle R2 is equal to the angle PQR. So the angle R1 plus the angle R2, this one here, is equal to the angle PQR, this one here. Why is that the case? Because this one is a tangent, and this is a tangent. So that is the Tan-chord theorem. Tan-chord theorem. Right, this is the Tan-chord theorem. Tan-chord theorem. In the same way, we're able to see that the angle S4 is equal to the angle PQR. That one we've already proven. That the angle S4 is equal to the angle PQR. So we have, therefore, that the angle S4 is equal to the angle PQR. Why is this the case? It has been proved. It has been proved in 10.1 above. In 10.1 above. So the angle S4 is equal to the angle PQR. Okay, because we said S4 is a R3, but PQ is equal to PR like this. Because we have been told PQ is equal to PR, so that the angle R3 is equal to the angle, this is the bow tie angles in the same segment, but these are equal because angles opposite equal sides. So we're able to see, therefore, that at this point, the angle as 4 is equal to the angle PQR. Then we continue as follows. So therefore, the angle as 4, because this one is PQR and this is PQR, which means the angle as 4 is the angle R1 plus the angle R2. So if we have the angle as 4, which is equals to angle R1 plus R2, then we are done. Then we are done because the angle as 4 is like this. If the angle as 4 is like this, is equal to R1 plus R2, then you have grade 11 angles. This angle is equal to this angle here. And the reason for this is that you have what? You have that SMRC is a cyclic quad. SMRC is a cyclic quad. Why would this be the case? Converse exterior angle of cyclic quad. Converse exterior angle of cyclic quad. Right, because now you can see that the angle here is equal to the angle there. Like this. So this is like the exterior angle of a cyclic quad is equal to the interior angle. So opposite angle, so that the SMRC is a cyclic quadrilateral, a converse exterior angle of cyclic quad. Any problem with this? Any question? Anything you do not understand? Please talk to me. Any confusion? Any confusion? Any question, Lisedi? Maybe it's too easy. Maybe it's too easy. Any problems? Any question? Any question? Any question?
No,
No question. Okay, I can see that you possibly are able to understand this very well. You understand this very well. Here comes the next question. The next one is 10.3. Please try 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 10.3. Okay, now proof giving reasons that RP is a tangent to the circle passing through P, S, and A at P. So try this one. So try that question there. Try this question there. Right. So we continue. We continue. We continue. Proof giving reasons that RP is a tangent to the circle passing through P, S, and A at P. Please try that question. When you're done, please let us know. When you're done, please let us know. Please let us know. Right, please let us know.
So AP is already given as a tangent.
Yes,
So for
AP
us,
is a tangent, yeah?
yes, and then S3 equals to S4, right?
Yes.
Proven. So, and since AP is a tangent, for us to
Yes.
prove that um RP or PR is a tangent, we'd have to prove either it equals to 90 or, am I right? So
Please
with
come again.
perpendicular, do we
Yeah,
have
to
to prove
prove
that
that
it's
is a
equal to 90?
tangent, you need to prove that it's a tangent, you can prove that tangent is perpendicular to radius. Or you can prove the
Okay.
Tan-chord theorem. You can prove that a Tan-chord theorem is satisfied there.
Yeah,
So
so
you have those options, of course. Then you have those options there, of course.
yeah, so
Okay, so continue.
okay, I think I see.
Okay, what do you see?
So I see a triangle APS.
Okay, good. A triangle APS.
Yes,
Okay,
Hold on. AP is.
Yes. Okay, that's easy. Thank you so much
Hold
for
on.
trying. Okay, that's fine. So the couple of things that obviously we need to take into account here, and the couple of things we need to prove in this case and establish. Right. So the couple of things we need to prove here,
Yo,
and
wait, so
couple of
can I please
things.
go fetch a
Oh,
charger? My
okay, that's
laptop's
fine.
about to
Okay.
die.
All right. Okay, good. Let me give you a chance. Hello, Shingi. Good. Let me call you after my class. I'm in class now. I'm in another class. You know, I just have a string of classes on weekends. I take advantage of the weekend to teach more. Yeah, so, but I'll let you know as soon as I'm done tonight. Okay. Okay, thanks, Shingi. All right.
Okay, so I'm back.
Okay, good. I'm glad that we are right back. Okay, so now I want us to I wanted to prove this with you because but just to demonstrate because you're thinking about it and it's okay that you're thinking about it. I'm glad that you think about the questions. But one thing to prove, we'll have to prove that the easiest way is to prove that the angle P2, if you can prove that the angle P2 is equal to the angle, for instance, A2, then we are done. Because RP want to show that RP is a tangent to the circle that passes through P, S, A, and P. P, S, A, and P. So so need to prove that P2 is equal to A2, then this is going to be like the Tan-chord theorem because you're going to have something like this. You're going to have clearly something like so. Something like so. With these, then you're going to actually be exactly done here. So we start by saying the angle S3, first things first. Right, we note that the angle S3 is equal to the angle R2 plus the angle P2. Why is this the case? The angle S3 is actually exactly equal to the angle R2 plus the angle P2. And because we want to just deal with the angle P2, but to bring the angle P2, it's easy to say S3 is R2 plus P2, and this is exterior angle of triangle. But also, if you have the angle S4, the angle S4, the angle S4 is equal to what? If you look at the angle S4, you can be able to see that the angle S4 is actually exactly equal to the angle P1 plus the angle A2. Let's check that one. So the angle S4 is actually exactly equal to the angle S4 is actually equal to the angle P1 plus the angle A2. Yeah, because this angle S4 is the exterior angle of triangle from grade 10. So this also is the exterior angle of triangle from grade 10. Exterior angle of triangle. But the angle S3 is equal to the angle S4, and this has been proved in 10.1 above. So now S3 equals S4 from this, which means S3 is R2 plus P2. S4 is P1 plus A2. But The angle P1 is the angle R2. Why is the angle P1 equals to angle R2? Because this one is a tangent. And this is the Tan-chord theorem. Tan-chord theorem. And if this is the case, so you have that the angle P1 is equal to the angle R2, which means the angle P2 is equal to the angle what? Is equal to the angle A2. The angle P2 is equal to the angle A2, and therefore, RP is a tangent. RP is a tangent. RP is a tangent to the circle. It's a tangent to the circle. The reason for this is converse. Converse Tan-chord theorem. Converse Tan-chord theorem. Converse Tan-chord theorem. Any question? Because now we have already we have been able to show that the angle P2 is equal to angle A2, and according to this is the Tan-chord theorem. But this is the converse of the Tan-chord theorem, so that indeed RP is the tangent, because this is the Tan-chord theorem. So if you have a circle like this, a tangent here, then you can be in a position to see that this angle that sits here is equal to the angle that sits here. And this is the Tan-chord theorem. Is the Tan-chord theorem. Is the Tan-chord theorem. Right, so obviously you have the Tan-chord theorem in that manner, but also if this angle here, the angle tangent to the circle, and chord equals the angle in the alternate or in the opposite segment. Angle tangent to a circle and a chord equals the angle in the opposite segment. And this is called the Tan-chord theorem. Any question on this one so far? So we've been able to prove 10.3. Any problems?
No, sir.
Right. Yes, definitely. Any question? Any question? Do you understand?
I'm getting a better understanding now, sir. Thank you.
What would you think is the problem? Where would you think you don't understand? What explanation would you need here? We are not running away. We are taking our time to understand every single bit of thing.
I started off by saying S4 equals to S3. Then I said
Yes.
S3 equals to R2
Yes.
plus what? I think I said R1. I don't know if I wrote this clearly.
Okay.
And then,
But we're on the right path, isn't it?
yes, sir. And then I said
Mhm.
S3 again equals to, no, then I said R2 plus R2 plus P2 equals to S4. Then I said
Yes.
S4 equals to R3. Then that's how I stopped, sir.
Oh, I understand.
Yes, sir.
Okay. That's awesome. Right, that's fine. But I'm glad that you saw something. You learned a thing from this particular question here. And geometry is all about practicing. It's all about learning how to prove things. Okay, so I'm glad that you're able to prove things. You're able to understand. You're able to interpret this particular question. You're able to interpret this particular question. We move forward. In the diagram, Right, just look at similarity and proportionality. In the diagram, ABCD is a parallelogram. ABCD is a parallelogram with AB equals 14 units. Right, so we have that AB is actually 14 units. AD is produced to E. You have AD is produced to E such that AD to DE, the ratio is 4 is to 3. EB intersects DC in F. EB is actually exactly 21 units there. So you have that EB is actually exactly 21 units, exactly like so. Right, calculate giving reasons the length of Facebook, FB. Calculate the length of FB, the length of Facebook. You have 3 minutes to do this one. Too easy. Too easy. Too easy. Too easy. Right. You have exactly 3 minutes to find the length of Facebook, the distance from F to B, FB. The length of Facebook. The length of Facebook. Right. It is a practice session.
AD over.
Yeah.
I'm almost there, sir.
All right. Is it too obvious, this question, Lisedi?
No, sir.
All right. Obvious, I'm going to give corrections to everything.
Okay.
I've solved all these questions myself. I'm already done solving everything, but I must give you a chance to try also.
Yes, the thing is, I haven't touched Euclidean in a long time,
I
so I'm just
understand.
struggling a bit.
Yes, I understand. Okay, that's fine. All right, you have 2 minutes. You have 2
So,
minutes. Yes, too obvious.
no, I'm not sure, hey? What I did, I said AD over ED equals to FB over EF.
Okay.
And then,
Did that give you an answer?
no, not really.
Okay, I see. All right, I
Wait,
see.
can I see another method? Hold on.
All right, that's okay. All right. Right. All right. Yeah. Practicing geometry,
Okay,
Euclidean
so
geometry. Yes.
I don't have any other theorem in mind
All right, that's
because,
fine. That's okay because we're practicing. That's okay because we are practicing. And so what we are effectively doing here, this is too easy. You can do it with your eyes closed, but let's start as follows. This is the solution to the problem. I've already solved this question myself, and this is what I had to do in solving this particular question. We begin as follows.
oh, I think I see something.
You think you see something,
Hold on. I just want to see before I come to conclusions.
okay? Okay, there's something we need to remember from grade 12.
Yeah, I think I see something.
Okay, I'm glad if you're seeing something. So if you
So,
look at A, B, C, D, E, right, and you have this is parallel to this. So you'd have therefore that AD over DC is equal to AE over EB.
that's what I wrote down.
Okay, good. And this is called the prop theorem. It's
Yeah.
called the proportionality theorem, right? So now when I use it, this here, so now what you then going to have becomes the following. It becomes exactly the following. So
So
now,
you see when I wrote down that, so
yes, yes,
because we only have for one side, we have the ratio for one side,
yes,
which is 3 over 4. So I
yes.
only had one side, so the other side was FB over EF. So that's where I was stuck.
Yeah,
So
that's the thing.
right
So
now,
we have FB
E-
over, we can take, for
EF.
instance, now let's do it this. So you can take FB over EB. That is it. You can take FB over EB, and then you're gonna take a DA
Okay, so I think I see
over
now.
EA over EA. Why is this? This is the prop theorem, proportionality theorem. This is the proportionality theorem with
So it's 12
D
units.
parallel.
So
It's 12 units.
yes,
Well
sir.
done. It is 12 units. Exactly. It is 12 units. Right. So it is actually exact proportionality theorem. So that at this pointer, you have Facebook. FB is exactly equal to what is DA? Right.
Pardon?
Because already, okay, you have DA or AD, and
It's 4
you have,
units. It's 4.
yes, it's 4 units. So now when you have this DA, you have 4 units, and then you can call for X. And then now, if this is the case, you have obviously your dA and also your dE is also 3x. So that
So you not
now if we
added.
have, yes, so you can add them up. Obviously, because when you're dealing with the dA, you have 4x. Right, but if you're dealing with EA, you have exactly what? You have exactly 7x. Right, you multiply everything. The EB, you already know. EB is 21, and therefore FB is the same as 7 cosine times into 21. It goes at 3 times, and then 3 by 4, it's 12. The x cancels the 12, and therefore the x cancels the x, and therefore we have units here. And therefore, as a consequence, this is what we have exactly.
So I went EA, so
Yes,
the whole of EA
yes.
over AB.
Okay, the whole of EA over
AD.
yeah, AD. Yes, yes, that's correct.
And then I went the whole of BE over FB.
That's correct.
Yeah. And then that's how I got to the
Super.
12
Yeah,
units.
that's super correct. That's super, super correct. And then now we found FB, which is 12 units. Any question?
No, sir.
No question. Okay, so prove with reasons that the triangle EDF is similar to triangle EAB.
Um, Parallel.
It's rather similar. Right,
Okay, you
prove with
can.
reason that triangle EDF is similar to triangle EAB. So we have EDF, it's similar to triangle EAB. Yeah?
Okay.
Okay, you have this one is too easy. You have 2 minutes.
Okay, I got it. I think I got it.
You think you got it?
Can I explain it while I write
Yes,
it?
please. So now let you need to explain. Yeah? Explain, please.
Triangle EDF is similar. The reason angle E equals to angle E,
Angle E
common,
equals angle E common, yeah?
common, and then you can say angle D equals to angle A,
Angle D
corresponding
equals angle
angles.
A, meaning the angle EDF is equal to the angle A. And the reason for this is that these are corresponding angles, yeah?
Yes. The
Corresponding
parallel
angles
lines.
with EA parallel to what? To CB. Next.
And then now it's just the leftover angle. Angle F equals to angle B, sum of
Angle
interior angles.
EFD is equal to the angle EBA. And the reason for this is what? These are corresponding angles. Why would this be the case? DC is parallel to AB. So therefore, so now to start off here, we say in triangle EDF and triangle EAB. So then you have that the triangle EDF is similar to triangle EAB. And the reason is angle, angle, angle. The reason is angle, angle, angle. So we've proven this one, obviously. So too easy, right?
Yes, sir.
Good. Let's move on to the next one.
Um, I just stated it's 14 units. The reason being
Yes.
DC is parallel to AB and AD is parallel to
You mean this
BC.
one? You mean this one?
Yes, sir.
What did you get?
Oh, FC. Oh, no, 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 no. Never mind. Hold on.
Okay, that's fine. I wanted to know because I've already solved it myself. I already know the answers. But I want to see what you can do. What you can do. I want to see 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 what you can do here. Right, you're done.
So I'm not sure. I'm just assuming. Yeah.
Okay. Okay. What answer did you get? Have you got an answer yet?
No, I'm not sure.
Okay, we're giving you 2 more minutes. We're giving you 2 more minutes. 2 more minutes.
Oh, okay. Okay, so I think I see a formula, but I'm not sure. I'm going to try implement it now.
Okay, that's fine. And then let me know when you're done, please. Because we're not running. The aim is not to solve. Sometimes it's not. It's better to. The aim is not to solve 1 million questions. The aim is just to solve one question and solve it very well, and you understand it. Then you're good. Than to solve 1 million questions that you don't understand. How far?
Sir, I'm not sure. I'm drawn a blank.
Right. Please come again.
I'm drawn a blank.
Okay, that's fine because we are practicing. And the aim of our discussion is to practice more and more. And that's what we want. So we practice more and more.
My name is Bonolo Motsu.
So let's practice together. Let's practice together. 9.3. So the easiest way to do this is to actually then realize that these angles here are, these triangles are similar. So you start off by noting that triangle EDF is similar to triangle EAB, and these are similar triangles. Okay, if these are similar triangles, then it means you can take ED over EA. So if you take ED over EA is equal to, then you can take DF over AB. So you take DF over AB, and then you can take EF. EF over AB. EF over EB. Right, so you do EF over EB. And at this point, these are similar triangles. Then now we're going to choose some parts of this. DF. Then we have ED, which means that you can take ED over EA is equal to DF over AB. Getting DF DF, if you cross multiply this, is equal to ED over EA AB. Then you need to look at ED. Right, ED. ED, you can call it 4P. And then AD, ED, you can call it 3P. Yeah, you can call it 3P. Let's call this one 3P. Right, so if you call this one 3P and then you have AD, you can call it 4P. So that ED is what? Is 3P, and then you can deal with EA is 7P, and then you deal with AB, right? And AB, you already know, right? AB is 14. So 7 goes how many times? It goes 2 times by 3, which is exactly the following. So you have 6 units. So DF is 6 units. So once you have that DF is 6 units, then you can get FC. FC is going to be exactly 8 units, because 6 plus 8 is what? Is 14, and this
14.
is a parallelogram, and this is a parallelogram. So which means that FC is actually exactly 8 units, because in a parallelogram, the opposite sides are equal. If this is 14, that is also 14 there. And the reason for that, for this to be 8 is therefore that DC is equal to AB equals 14 units, which means the opposite sides of parallelogram. Opposite sides of parallelogram. Opposite sides of parallelogram. So FC is exactly 8 units. FC is exactly 8 units. FC is exactly 8 units. Any question?
No, sir.
Too easy. Right, let's try the next one. In the diagram below, A, B, C, and D are points on a circle having center O. If A, B, C, and D are points on a circle having center O, PBT, the tangent to the circle at B, right, reflex BOC is equal to the angle O1, right, reflex BOC is equal to the angle O1, which is 310 degrees, as shown in the diagram below. Calculate, given reasons, the size of the angle D1. This one.
Okay.
The size of the angle D1. Too easy. You have 2 minutes. You have exactly 2 minutes. So you have 2 minutes.
It's in D150.
Let's check it out. What would the reason be for that one there?
Same segment.
Angles in the same sag. Okay, well, obviously because the D is not on the, O1 is not on the circumference of the circle. O2 is not the circumference of a circle. So, I mean, it will be in the same step with which one?
So wouldn't it be, since O is the center, and then
Yes.
B is the circumference, D is the circumference.
Yes. So you would say, what, say, please come again. I want to make sure I understand you well.
So O2 equals to 50.
O2 equals 50 degrees. I need a reason, please.
Angles around the point.
Angles around the point. Good. Angles around a point. Now, that is correct. Angles around a point. Next, we're interested in the angle D1.
Oh,
So
so
what is
wouldn't
the
it form
angle
a bow
D1?
tie?
Please come again.
Bow tie segment from OBCD.
Because we're practicing here, we're just having a discussion on geometry to equip you with geometry skills. Yes, we're still interested in the angle D1. Right. So we continue. So we continue.
Okay, so if that's not the oh, hold on.
Yes. Okay. Right. We continue. Right. So we continue. So we continue. How far? We need D1.
Still thinking so.
Okay. How far? From grade 11, we know very well that if you have a circle like this, the angle at the center is actually 2 times this angle here.
So, but which one is the circumference since it touches both B, C?
Yeah, so in other words, the theorem is like this. If you have the angle at center is 2 times the angle at circumference, so you'd have exactly the following. Right, you'd have this. So you can have the angle at the center, 2 times that, which is the same as this. Angle at center is 2 times angle at circumference. Angle at center is 2 times angle at what?
Circumference.
At circumference. So there's an angle at center is 2 times. So these two are the same. So in this case, it would mean the angle O2, this one here, is 2 times the angle D1.
2 times angle D1.
Yes. So angle at center equals 2 times angle at circumference.
Oh.
So right now,
Well, but is it not supposed to be like angle, even with angle C, but like angle B1 is too small to be 155. It wouldn't be like angle C2 equals to 155 since it touches the.
well, I mean, what we know is that angle O2 is 2 times D1.
Okay.
Right?
Oh, okay, yes, okay. Thank you, sir.
Yeah, because of the fact that if you look at it, angle at center is 2 times this angle here. Angle at center is 2 times this angle there. Divided by 2 means the angle D1 is 25 degrees. Angle D1 is what? Is 25 degrees, which is something you sort of purported. You actually purported that. It's something you purported.
Where's angle B3? Okay.
Right, so that's something you need to take note of.
Um,
Right. So that therefore, obviously, we have that angle D1 is what? Is 25 degrees. Next question. The angle B3. This angle here. The angle B3.
B1 spent 3 equals 90, am I right, sir?
Please come again.
B1, 2, and 3.
Yes.
Okay, thank you.
Because it's tangent perpendicular to radius.
Yes, sir.
Okay, good. Right. So now what do you then think? Obviously, you need to think about B3 and what the size of B. These are like pause metric questions. They're not just questions we're just bringing, they're like pause metric questions.
So
Yes.
his angle, would I be wrong if I were to say, okay, never mind, never mind, never mind.
Okay.
Oh, angle O2 equals to angle B3.
Okay. What do you think the reason for that?
So wouldn't it be Tan-chord theorem?
Okay, that's interesting because Tan-chord theorem is to do with a shape like this. It's to do with a shape like this. So you have the angle between a tangent to a circle and a chord equals the angle in the opposite segment.
Okay.
Or an angle that's here is equals to an angle that is there. So what do you think the angle B3 is here in 8.2?
So
Yes.
so what I did, I said OB equals to OC
OB
from
equals
the C.
OC.
Yes, sir.
Right? Yes, that is true. OB equals OC, the radii. Each one
Yes,
is
sir.
equal to radius, yeah?
And then since they are equal, sir, equal length, equal sides, opposite equal sides.
Yes.
So then I just did sum of interior angles of a triangle. I've already
Yes.
calculated that O2 equals to 50. 180 minus 50.
O2 is 50, yeah?
180
O2 is
minus
50
50 is
degrees,
130.
yes.
Divided by 2.
Yes.
Divided by 2 is 65. So angle B1 plus angle B2 equals to 65.
Mm-hmm.
And then knowing that B1 plus B2 plus B3 equals 90, I just said 90 minus 65 equals to 25.
All right. So if you look at the shape I'm just doing now, this is exactly the Tan-chord theorem here. But you already know that the angle D1 is 25 degrees. So that the angle B3 is equal to the angle D1, which equals 25 degrees. Why would this be true? Tan-chord theorem. Tan-chord theorem. So we're sure, therefore, that B3 is equal to this, like it is in the Tan-chord theorem. So which means that B3 is equal to 25 degrees, and this is the Tan-chord theorem. Tan-chord theorem. Next, calculate giving reasons the size of the angle B1. Calculate giving reasons the size of the angle B1. Calculate, giving reasons, the size of the angle B1. Calculate, giving reasons, the size of the angle B1. What do you think? The size of the angle B1. Right, the size of the angle B1.
Not sure, eh? I'm not sure, sir.
Yeah, you're not sure.
Yes, sir.
Yeah, but it's too easy. So we continue. Right. What is B1 in your view? What is B1 in your view?
I don't know, sir.
Mm-hmm. How far, Lisedi?
I'm still stuck, sir.
What is the problem?
I'm not sure where to begin.
So we continue. What is the answer? What is the answer? What is the size of the angle B1? What is the size of the angle B1? How far?
Still stuck, sir.
But it's too easy. It's too easy. So we continue. How far? So we continue. How far? See, the angle A is 60 degrees. Right, and obviously if the angle A is 60 degrees, this is a cyclic quad.
Okay, so I think that's C.
Okay?
Angle,
Yes.
let me see.
Okay.
Would it not be 30?
Okay, that's interesting. Would it not be 30? So we need to investigate that and check.
Okay.
Need to investigate. So which means that the angle BCD Must be 120 degrees. Opposite angles of a cyclic quad. (120). B2 is 35 degrees.
Since if B2 is 35 degrees, we calculated B3 to be 25.
Yes, because this one is 20. This one is 20. D1. What did you find D1 to be? Yes, found this one to be 25.
And you said
because
B2
this is
equals to
25 and this
35.
is 50. Yeah.
And
Okay.
if you say
So
B2 equals 35, wouldn't
yes,
B1 equal to
yes,
30?
the sum of angles of a triangle. The sum of angles of a triangle. Okay, so
Therefore, B1 equals
because
30.
this one is 90 degrees.
Yes, sir.
Right, and therefore, obviously now the angle B2 here is going to be exactly 35 degrees. Sum of angles of a triangle, because it's this plus this plus this must be 180. But if this
Yes,
is
sir.
120, then you add 35 plus 25, you get what? You get exactly 60, which is a plus 120, which is 180. So now you get to this one. So B1, it's easy from there.
B1 is 90 minus 35 minus 25, which equals to 30.
Yes, definitely. So in other words, the angle B1, so you have that the angle OBC is equal to the angle OCB, which is equal to 65 degrees. The angle OBC is equal to the angle OCB, which is equal to 65 degrees. These are angles opposite equal radii. Therefore, the angle B1, therefore the angle B1 would be exactly 65 minus 35, which is the same as B1 is equal to 30 degrees, and these are radii. Okay, this is the case because so this is one way to do it, but as said already, you can use also the other way we've done. So similarly, you can say that the angle B1 is 90 degrees minus 25 minus 35. And this because the tangent is perpendicular to radius. So that the angle B1 is equal to what? This is exactly 60. That means is actually exactly 30 there. So which means that B1 is 30 either way. Any question? Good. Let me check. All right, good. Right, we're done. Thank you so much for joining us. It was awesome. I'm going to send this recording tonight. I'm also going to use the email you sent, the email you gave me yesterday to send you the recording. Thanks again for joining us. Until tomorrow, take care. Goodbye. God bless. Good night. Goodbye.